So I'm going to start my presentation with a high-level overview of global impacts of 2050 net zero goals and try to tie it to harvested coal ash and show how it can be a solution in producing low-carbon cements and concretes of the future. All right, let's get going. According to a UN survey on socio-economic affairs, there's a steady shift in population. People are, moving to big cities, and the report estimates that up to 70% of the population will be living in the cities by 2050. More? Okay. How better?
Yeah, just for the back.
Yeah. So what does this globalization do? It puts a lot of pressure on the cities. These cities continue to grow, and which will also put a pressure on the supply chain of the construction materials, which is already strained. The report says the DMC, which stands for domestic material consumption, is expected to double by 2050. I Googled what DMC stands for. Basically is the total amount of material used in an economy, including materials extracted domestically and imported, excluding the material exported. It is measured per ton per capita. Here's a chart that shows for different regions what is the expected growth look like compared to 2010. This is in Africa, this is in South Asia, Southeast Asia. So across the board, they're all showing that it is expected to grow, and on an average, it's supposed to double by 2050. Most of us have seen this chart. This is from Portland Cement Association's Carbon Neutrality guide. This is also saying that by 2050, the concrete production in the US is going to double. Agrees with the DMC report. So current production in the US is around 350 million cubic yards, and across the world it's 5 billion cubic yards. And in terms of cement consumption in the US is around 88 million tons, and around the world is around 4 billion tons. These are huge numbers, and imagine them doubling. So while the concrete is expected to double by 2050, cement production is only going to see a marginal increase in production. This is because of the greenhouse gas emissions associated with the cement production. Probably the most abused statistics in the construction industry. Every ton of cement produces close to a ton of CO2. So this is the reason they don't want to double the production of cement. So how is the cement industry going to support this doubling concrete production? There are several ways the cement industry is focusing on, but one of the main sources that they're looking into is increasing the cement production without actually increasing the clinker production. They're reducing the clinker content and increasing the supplementary cementitious materials, aka they want to produce more blended cements. Blended cements, in addition to meeting demand, increased demand, also aid in GHG reductions. Obviously, lower the clinker, the greener the cement. So back in the day, we had ASTM C150 cements, which had up to 95% clinker. That was close to a ton of CO2. Now we are using limestone cements. They have clinker up to 85%. That reduces the GHG. The end goal is to produce ternary cements and performance-based cements, which will have a clinker content around 40 to 50%. That's almost like a 50% reduction in GHG just by dropping the clinker content. But to do that, the cement industry needs a lot of high-quality SCMs. And when we talk about high-quality SCMs, sustainable SCMs, and large quantity SCMs, we tend to think about coal ash and slags. However, the same 2050 net zero goals that led to GHG strategies in the cement reductions is also leading to supply shortages in coal ash. Here's a chart from US Electricity Generation Energy Information Administration. This basically shows that by 2050, the electricity produced in the US via coal is going to be around 10%, no more than that. Rest of it is coming from renewables, nuclear, and others. This strategy is leading to coal power plant shutdowns. Power plants are scheduling shutdowns, which is leading to lower fly ash in the market. Now, if you compare that to slag situation, there's an order of magnitude difference between the blast furnace versus electric arc furnace. This is forcing the steel producers to switch from blast furnace to electric arc furnace, which is leading to shortage in GGBFS. Here's another chart from this. I think this is what Cole was talking earlier. It's another representation. As the power plants are shutting down, the coal ash is going down, while the consumption of ash is actually going up. This is again due to the GHG strategies in the concrete side of the business right now. So if you compare a concrete, 40 MPa concrete made with general use cement, you get certain GHG over here. Now if you replace that cement, straight cement, with type 1L or GUL plus fly ash, you get an immediate reduction of global warming potential up to 25%. So to reduce the gap between the supply and demand, the industry stakeholders are focusing on harvesting coal ash. According to an estimate, this is what, again, Cole was talking earlier, according to an estimate, there are over 740 coal ash storage sites in the US with over 2 billion tons of reserves. Of course, not all of those sites are suitable for harvesting, as they could be commingled with other plant waste like FGD, flue gas desulfurization product, or they could be far away from the population densities where these SCMs are required or in demand. So in situations where these storage sites are not contaminated with FGD, and also are in the sphere of influence of big cities where the demand is high, harvesting is a solution. Currently, both CSA and ASTM specifications have approved harvested ash as a mainstream supplementary cementitious material. And in some cases, harvested ashes do contain ground bottom ash. ASTM went a step further and established a guidelines for characterizing the CCR in the landfill and also harvesting it. Cole did a great job in explaining what harvesting looks like. I'm not going to get into more details, but essentially it involves these steps. Okay, reclaiming and feeding, which involves site engineering and permitting, CCR excavation and hauling it to the feed bin. Drying, as Cole was saying earlier, these harvested ashes generally contain certain amount of moisture because they were added, and also they were sitting in the landfill accumulating all the moisture. So they need to be dried. Usually this process involves a natural gas-aided drying process. And then comes size control, which we want to make sure all the ash that we are harvesting and producing is uniform in its characteristics in fineness. Generally this is done via vertical mills, ball mills, or attrition mills. And in some cases when the harvested ash contain high amounts of carbon, that needs to be addressed. Usually these are done via carbon extraction units or burn-off units. And the next in line is storage, where the product is stored and shipped to the markets. Now, obviously, this is a concrete conference. In the next few slides, I'm going to show performance and durability aspects of concrete that we developed using our Battle River RAM ash. RAM stands for Reclaimed Ash Management. It's an Ashcor proprietary technology that we use for harvesting. Here's a stats on our Battle River RAM ash over the last 3 years. Basically an average of weekly milsers that we generate on our production. The one thing that I want to highlight with this chart is the consistency in the product. So we took that Battle River RAM ash and we made a few different concrete mixes with 3 different GUL cements that are famous in this region of Ontario. GUL1, GUL2, GUL3. We replaced the GUL all GULs at 10% and 25%. Our target was 30 MPa at 28 days, and the water was fixed on all these mixes. As you can see, all the concrete mixes met the requirement of 30 MPa. And it did not stop there. The reason I put this chart up here is the concrete continues to gain strength without compromising any strength. So by 1 year, they're almost close to the control. Here's results of accelerator motor bar test, the ASR test. The control, 10% replacement, and 25% replacement. As you can see, at 25% replacement, concrete shows high resistance to ASR. Results from RCPT and bulk resistivity, again, Again, at 25% replacement, significant reduction in chloride permeability and improvement in bulk resistivity. Another result on sulfate resistance. Control, 10%, 25%. Again, samples with 25% replacement show very high resistance to sulfate attack. We're still waiting on results for freeze thaw and ASR. Hopefully by next time when we are doing this again, I'll have those results to share. So if I were to summarize the previous results, when we replace GUL with our ram ash at 25%, it costs less. The GHGs are low without compromising the strength. Sulfate ASR performance is improved. RCPT is improved. Bulk resistivity is improved. Sulfate resistance is improved. So, to conclude, irrespective of political landscape, the 2050 net neutrality goals are not going to go away. Or this is just my opinion. All studies point towards increased demand for concrete and sustainable construction materials. To meet these increased demands, the cement industry is adapting the carbon management strategies, CCUS and others, and among the strategies is clinker reduction strategy. So having consistent supply of SCMs like harvested coal ash is one of the key in producing these sustainable low carbon cements and concretes in future.